the ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey. Forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and excuse me, and things gonna improve slowly, because you can't reach down top before top player.
There was a time when immortality seemed the way to enchantment and happiness.
Alright, brothers and sisters, so we live again. So this we have a trigonometric integral. So we have to integrate this question here. Integral tan of x sec 4x dx. So now how are we going to do this? This is very easy question, brothers and sisters. So first and foremost, how do we know this is trig integration? Because I have a trigonometric there. So first I'm going to have to play around with those trig identity and see how I can come out with a solution. So I'm going to come out of the solution. So first and foremost, before we start to solve this question, let me try to figure out in trig how I'm going to get tan and sec. So we have a better basic identity, which always say if you have a sine, square of angle, let's say x for this case because we use x, plus cos square of the same angle always equal to 1. So I want to produce tan and sec. So what is sec? Sec, if you have a 1 over cos of anything, let's say of theta, this same say sec of the same angle theta. So now, since I want to get sec, so it means I'm going to say, okay, if I divide by, I want to get sec, right? If I divide by cos, by which angle? X square, excuse me, because you see what I'm saying? This is going to be 1 over cos square is going to give me sec. But whenever you're going to divide here, you have to divide throughout. So that means I'm going to divide by cos square also here, cos square, and here I'll do the same thing, cos square of angle. So cos over cos square equal to 1 equal, and here we have a plus, sine over cos equal to tan. I believe everybody know that sine over cos equal to tan, and then 1 over cos equal to sec square of angle. So this identity is very important, but how you get it? Started from here, like I said. See, so we're going to use this identity because in our question we have a tan and sec is involved, so that's what we're going to use. Now let's go. So I'm going to say I'm going to replace this with is equal to sec power 4, means I have to say sec square times sec square, so I can get sec because this sec power 4. So since I have a sec square in my identity, let me make that sec power 4 into square format. So I'm going to say this equal to tan integral, and then I'll say square root of tan, square root of tan, and then this sec power 4 means let me say sec square x times sec square x, and then I have a dx. See that? So now another things I'm gonna say from differentiation, right? So I'm gonna do substitution. How I'm gonna do? Let me let this term equal to any letter. Let's equal to u. So I'm gonna say let u equal to tan of angle, and then I'm gonna differentiate. When I differentiate, it's gonna give me the u here because you differentiate u, and the right hand side when you differentiate tan, you get sec square. So this is gonna give me sec square of angle, but since I differentiate x, so it has to be dx. Okay, so next step here. So this meaning du, because sec square dx equal to du, and this tan equal to u. So I also need to write this sec square into u as well, just like others. So now I know from here, so I know sec square, look, sec square, what is a sec square? Sec square x equal to tan square plus 1. But what is a tan square? Tan square equal to u, so we'll say u square because tan square, and tan equal to u square plus 1. Alright, so everything is in u, so I can take this and replace in equation. So equation now is going to be u, and that's what I call this is a trig substitution, because it's trigonometric, but I will do substitution. Now let's do the substitution. So integral tan u means I'm going to say square root of the tan. but the time now is u, so we're going to say u. But the square root, what does square root mean? Square root means what? A half. And then multiply. Sec square means u square plus 1. Now sec square x dx, sec square x dx equal to du. You see now the equation, now you went to the power form of integration. So now what we're going to do, we're going to multiply this out in, excuse me, so it's going to be integral u a half, or let me write down, excuse me, let me go down and I'll go down next page. So this is going to be integral u a half times like u a half times u by this power 1. So when the base are the same, you write only 1 and then you add a half, excuse me, this is 2, my apologies, this is 2. So a half plus 2 equal to 5 over 2. So this is going to give us u, and then have 5 over 2, and then we plus u a half times 1, it's going to be u a half, and then have a du. So what we're going to do here, we're going to integrate. So the equation is finished, because whenever you have, let's say, integral of, let's say, x, let's say n dx, but this n should not be equal to -1. Remember that. N should not be equal to -1, and then you're going to say, I'm going to take this x and then take this power plus 1, so n plus 1, and then you divide by the same thing, n plus 1, and then you plus constant, because we don't have a limit. So you're going to do the same thing here, because you're going to integrate the first one and then going to integrate the second one, because this is power in power form. So I'm going to say, let me separate first. So integral of u 5 over 2, and then we're going to say what with du. Separate means integrate to the first one, and then we say plus integral of the second one, which is u, and then a half, and then we got du. So next step now, we say, okay, the question is finished now. So, so let me finish the next page here. Excuse me, I mean next part here. So we say, right, so now I'm going to add 5 over 2 plus 1 is going to be 7 over 2. So this is going to give us, let me erase this part here, excuse me. So this is going to give us, excuse me, use out a pen quick. So this is going to give us, so we're going to add 1 here. It's going to be 5 over 2 plus 1 is 7 over 2. So when you integrate means you add 1, which is, so it's going to be u 7 over 2, but the same thing right underneath, may add the denominator, and then we plus, because there's a plus there, and then you're going to say a half plus 1 is going to be 3. It's going to be u is a half plus 1 equal to 3 over 2, and then write the thing 3 over 2. So the integral fall apart, and then we see plus c. So what you're going to do now, take these two here, because this is a fraction, so the number at the bottom go to the top. So this is going to be u 2u 7 over 2, and then we plus u, the same thing here, 2 is going to go up, and they say 3 over 2, and then over these 3 here, mean this is going to come here, and this is going to come here. So we're going to have a u 3 over 2, and then we plus our constant. So next step now, we just want to play around with the factorization. So now look, this is 7 over 2. Man, let me, I hope you don't mind, let me write it again clear, because there's a lot of dead to work here. So I want to say these two go to the top, so it's going to be u 7u, and then 7 over 2, and then we're going to have what? 7, and then we plus, these two is going to go to the top, so it's going to be 2u 3 over 2 over 3. So next step now, look, I want to factorize something which is common. So what is that common? Look, 7 over 2, 3 over 2. So I want to also produce here 3 over 2. So look, if somebody give you 7, let's say 8. So I could say this is equal to x. If somebody give you x power 8, I could say x 5 times x power 3. It's the same thing, because if the base are the same, you write only one base, and then you add the top, which is going to be 5 plus 3 equal to 8. So it doesn't make any difference. It's the same thing. So now I'm going to say, if somebody give you, excuse me, somebody give, let's say, x a half times x a half again. This time you say, you write only one base, and then you add the top, which is going to give you 1. So I could take 1 and split it into 2 parts. I say, okay, if somebody give me x power 1, this is the same as say x, I could say equal to a half times x a half, because when you add this, it's going to give equal to 1. Or you could say this equal to x 1 over 4 times x 3 over 4, because if the base are the same, and I'm going to write add the power, which is going to give me 1. So you can break however you want. So for my case here, when I break, I have to be have to Be very smart. So I'll say, okay, so now how I'm going to do? I have a u 3 over 2. So I want to break so that I can get also 3 over 2 so I can take out. So I'm going to say this same as, so I have my 2 here. So I'm going to say u because I have a 3 over 2 here. So let me also introduce here 3 over 2. 3 over 2 times. Now I'm thinking, which number, like in this 7 over 2, which number here, when I'm going to write the fraction, when I add, is going to give me 7 over 2. Of course, it's going to be 4 over 2 for this case here. Look, u 3 over 2 times u 4 over 2. So what that means, look, bases are the same. So it's like u, and when you add this fraction, means the base is going to be the same. And when at the top is going to be 7 because 2 and 2, 2, and then when you add the top, it's going to give you 7. So u 7 over 2. So it didn't make any difference. Did it make? Nah, it didn't make any difference. So what we're going to say, excuse me, that's why I say for 7 over 2 is u 3 over 2 times u 4 over 2, which is the same as 7 over 2. And then we plus again, excuse me, at the denominator, we still have our 7. And then plus 2 u 3 over 2 over 3. But why am I doing that? Because I'm going to have a common and common, which is going to go out. See, common and common, which is going to go out. So let's go. Shows me. So what is a common for this case? Look, this is common and this is common. So we can factor out. Still I have my c here plus c. So let's factor out. So when you factor out, it's going to be 2 out. And then u is out. And then it's going to be 3 over 2. And then write a bracket because common for the first group or the second group. And inside I'm going to have it u 4 over 2 equal to 2, and then we plus, here is going to be left with only 1 because everything go out. So over 3, and this is over 7, and then we plus c. So guys, brother and sister, the question is finished because what we're going to do now, we're going to plug it back all the value of u. What is our u? U we say equal to tanx. So wherever there's a u, we're going to substitute tan of x. So this is going to be finally equal. So we have a 2, just a 2. But what is our u? U equal to tan of x. So tan x, but what? 3 over 2. So here is going to be 3 over 2. And then we're going to put big bracket. The question is finished now, so I'll plug it back. I'm just substitute it back. Okay, u is tan of x. So here we have a tan of x. And then square, and then over 7 plus 1 over 3, and then plus constant. And that's the final answer for the question. So if you have any question, guys, man, if you face on my channel, make sure you leave a comment and you can subscribe. If this video was helpful, just leave a comment, say, man, thanks a lot, the video help, or whatever. You can share with a lot of people, man. Peace a lot, man. Thanks a lot, man. Peace. Right, so another time again, this is let me just show everybody so that everybody can see clearly. This is Twana Wabantu Academy. I'm saying, and the aim or the purpose of solving this problem is everyone should access free, classic, quality education for all. Means, the aim